In the last class we discussed about the amplitude modulated detectors, how we can detect a radio wave and convert it into a frequency audio signal, or how we can recover an audio signal from a modulated wave. But in a receiving station, actually, in addition to the detector, some more functions has to be performed, because in the receiving station, the purpose of the receiving station is to receive the radio waves or the modulated waves transmitted by the broadcasting stations, and converting this received modulated or radio waves into the corresponding audio signals. The first stage of a receiver is to receive the radio wave, and the final stage is the production of the recovered audio signals into sound. In between these two steps, that is the receiving and the reproduction of the sound of the radio waves, we can have different steps involved in the system or in the receiving stations. So let's see what are the steps involved in the receiving stations. First of all, we will consider about the amplitude modulated radio receivers, that is AM radio receivers. The first step, I told you, the antenna or the receiver at the receiving station will intercept with the radio waves passing through it, so that it absorbs or it captures the radio waves which is passing through it. So the first step of this is the aerial or the antenna of the receiving station receives the radio waves which is produced. Now the second thing is that the radio waves which is intercepted by the antenna of the receiving station will have all the radio frequencies, so that we have to select the desired radio wave from it. For that we will use a tuned parallel LC circuit which actually selects the desired radio waves. Now another step in the case of a AM radio receiver is the selected radio waves is amplified by tuned radio frequency amplifiers. So first step is the radio receiver or the antenna or aerial of the receiving station receives the radio waves, and the tuned parallel LC circuit selects the desired radio wave. Then after the selected radio waves received are amplified by the tuned amplifier circuits, then this audio signal is recovered from the amplified radio waves. That is, we have already discussed this function. The detector performs this task, that is, it selects the audio signal from the radio waves received. After this audio signals are recovered from the radio waves, then they have to be amplified, and this is achieved through a number of audio amplifiers. Then the amplified audio signal then is fed to a loudspeaker for the sound reproduction. So these are the different steps involved in the case of a receiving system. First step is the antenna or the receiver receives the radio wave. The tuned parallel LC circuit selects the desired radio wave. Then the selected radio wave is amplified by a tuned frequency amplifier. Then this audio signal is recovered from the amplified radio waves, and this recovered audio signal is amplified by a number of audio amplifiers. Then after this amplified audio signal is given to a loudspeaker to produce the sound. So these are the different steps involved. Now let's see the different types of amplitude modulator radio receivers. So there are mainly, we can classify the radio receivers into two types. One is called straight radio receiver and another one is called super heterodyne receiver. The straight radio receivers are the receivers used in the early days. Nowadays, these straight radio receivers are not used in the radio communication system. Here, if you consider the block diagram of a straight radio receiver, you can see a receiving aerial here. This receiving aerial or the antenna intercepts all the radio waves passing through it. So it receives all the radio waves and is given to a radio frequency amplifier with a tuned parallel circuit. This RF amplifier with the tuned parallel circuit selects and amplifies the desired radio wave. So the selection and the amplification of the desired radio wave is done by the radio frequency amplifier with the tuned LC circuit here. And after this desired radio wave, which is amplified, is given to the detector circuit. And we have seen that a detector circuit actually have two components. One is a rectifier and a filter circuit. This rectifier actually removes the negative half cycle in the radio waves, and the average value of the positive half cycle thus obtained will have the same property as that of the audio signal. And then this rectified radio wave is given to the filter circuit of the detector, and this filter circuit filters out the high frequency carrier components in the radio wave, and the audio signal is produced. So the output of the rectifier is actually the audio signal recovered from the radio waves by this detector or the demodulation unit, and this audio signal is then amplified by a series of amplifying unit, which is audio frequency amplifiers, and this amplified audio signal is then given a loudspeaker for sound reproduction. So these are the steps involved in a straight radio receiver. Just again, once more I am telling you that the receiver receives the signal and the RF amplifier unit selects and amplifies the desired frequency, and this desired selected radio wave is given to the detector, and the detector produces the audio signal from it, and this audio signal is further amplified by audio frequency amplifiers and is given to the loudspeaker to produce the sound. Because of its low selectivity and sensitivity, this type of radio receivers are not used nowadays. Also, these straight radio receivers will have a high interference of adjacent stations. So due to these two reasons, low selectivity and sensitivity and higher interference of adjacent stations, the straight radio receivers are not used in radio communication system nowadays. Nowadays we will use almost all AM radio receivers will use a new type of receiver which is called a super heterodyne receiver. Here the received radio signal after the selection is given to a particular circuit called a mixer circuit, which converts the selected radio frequency to a fixed lower value, and that particular frequency is called intermediate frequency IF. So this is the additional thing in the case of a super heterodyne receiver when compared with the straight radio receiver. That means here the radio receiver is having a very high frequency that is converted into a lower fixed value, and usually all super heterodyne receivers will produce a frequency of 455 kilohertz, which is the fixed value, which is completed by a circuit called a mixer circuit. This actually contains a radio receiver or an antenna or an aerial which receives all the radio waves, intercepts this antenna, and this radio frequency amplifier with a tuned LC circuit produces selects the desired radio wave. So this circuit actually selects the desired radio wave, and also it is also amplified, and then there is an oscillator in the receiving unit which produces a particular frequency which is usually this 455 kilohertz greater than the radio frequency of the radio waves received or selected by the tuned circuit, and is mixed up with the mixer so that it produces a frequency of 455 kilohertz here, and which is given to the intermediate frequency amplifier, and then this frequency amplified intermediate frequency radio wave is given to the detector. The detector, after recovering the audio signal, is given to the audio frequency amplifier. So here we will have audio here amplified intermediate frequency radio wave is given to the detector, and the audio signal from the detector is given to the audio frequency amplifier and is amplified and given to the loudspeaker to produce the sound. So this is the block diagram of a super heterodyne receiver. Here what we have to note is that if the selected radio wave frequency is say some 600 kilohertz, then the oscillator will produce a frequency of 1055 kilohertz. Then the difference is that is the mixer produces a intermediate frequency which is equal to the difference of the frequency of the oscillator and the frequency of the selected radio wave, and which is a fixed value, which is 455 kilohertz. In super heterodyne receivers we will use 455 kilohertz frequency. So this is fixed so that we can have an amplifier, IF amplifier and detector circuit which responds to the frequency of 455 kilohertz always. And this super heterodyne frequency amplifier overcomes the limitations of the straight radio receivers like sensitivity and selectivity. This super heterodyne receiver will have a higher selectivity and better or improved selectivity and better sensitivity, and it produces very high radio frequency amplification. So this type of receivers are used in radio communication system nowadays. That's all about the amplitude modulator radio receivers. Thank you.